here we are. Yes. Hello everyone and welcome to lecture 1 of this Python series. And this lecture will basically cover all the topics for BSc IT Python programming subject. And today's first lecture is based on introduction. So let's get started. So the first slide is based on the Python programming language. Just some basic things about it. Uh, so the first thing here it says it's Python is a high level language. So by high level language, I mean that Python is very near to the languages which humans speak. So for example, it can be compared with English. Um, that will be very much evident when we move further and check some sample Python code. You will be able to understand it pretty well, and it's quite easy to learn and use to. Next, we have low-level languages. These are referred to as machine-level languages. So, one of the examples can be assembly-level language. Then, yes, we'll move further. So, why Python is called a high-level language is because first it needs to be converted into low-level languages to be run. So, that is the major thing or the major difference between Python and other low-level languages. So that's the main reason we have Python interpreter to convert the Python program into low-level languages. And then we have last point, which says that high-level languages are portable, which means that you can run your Python code, which is on Windows, also on a Mac OS, in the same way without few or no changes, because here only the interpreter is machine dependent. The code is machine independent. So that's the main thing to note here. So moving further, we will take a look into what are the internal workings of a Python interpreter. So on the left you can see image of the how Python code is executed, and this is taken from the reference book for the course. So first we have the source code, then we have interpreter, and then we have the output. So in this three steps, interpreter is kind of a black box to interpret. So on the right, I have included another image from datasciencecentral.com, which says that we have an editor here. So the image flows like this. First, we have an editor in which we code our program and save it as a .py file, and then this file is given to Python interpreter where we have a compiler and virtual machine. So the compiler first converts the Python interpreter into low-level language, and then this low-level language program is executed by the virtual machine. And why do we have library modules here is because if our bytecode refers to any external libraries, they have to be considered in order to execute the code. So that's why we have the library modules box here. And at last we have our output, which means running the program. So there are some examples, popular examples of Python interpreter, which are CPython, PyPython, PyPy, Stackless Python. Yes, and here we have one more link to get a little bit more, sorry, to get a little bit more detail about the internal structure of Python interpreter. So you can have a deeper look to understand more about the internal workings. Further, we are going to look how you can run Python. So basically there are only two modes. First one is the interactive mode and second is the script mode. In interactive mode, we go to command prompt or maybe to Python interpreter directly. So usually I prefer CMD because it's easy to get around with commands, and you just type in Python, you will get the prompt. That prompt is known as chevron and it is indicated by three right arrows. So yes, and what I mean by script mode is you write all your Python program and instructions in a file, save it as a sorry, save it as a .py file. After saving it as a .py file, you run the Python file as a whole at once. So that is a script mode execution. And the reason we use both these mode would be that for interactive mode, if you want to test certain, I would say, constructs of Python, or maybe certain calculations, how they work in Python, just short ones to get quick output, you will use the interactive mode. Otherwise, when you have multiple statements, you will mostly use a script mode. So I will go over this part of how to run a Python program when we install and verify the installation. So this point will be covered in that slide. Further, we have the history slide. This might not be very much important from the point of view of practical, but we can take a look to just get the idea behind why it was named Python and why it was developed in first place. So firstly, it was developed by Guido van Rossum, and he basically developed this language in order to work on a project called Amoeba, which included, which is a not included, which is a distributed operating system, and he named this language as Python because he was big fan of the British sketch comedy series called Monty Python's Flying Circus. So that's why he named his language as Python. And even though Python was developed in late 1980s, it was not until 1991 20 Feb where it came into um, public site where it can be used extensively. So it took bit of time to get people used to this language, but then after that Python climbed very high, and due to today data science applications, it has become the top language amongst all like Java, C, and C++. So yes, moving further, we are on the feature slide. So here the first point is easy to read, learn, and use. By easy to read, I mean that, as I specified earlier, that since Python is a high level language and very near to English, so it is very easy to use and also to learn and to read. So for now, in order to get some hint about how easy it is to read, I will open up some Python code here in bit second. Okay. Um, Summarize. Yes. So here we can see that there are certain ways to define a function, but if we just assume that this is a function, it is only defined with one keyword def, and then we have some comments here, um, some variable assignments, then for loop if. So it's, I know it might be a little bit daunting at first, but as you come to know how to use the keywords, trust me, it is very easy to use and write the instructions in this language. So moving forward in our lecture here, so the second point here is that Python is an interpreted language, which means that first the execution of the code is line by line, and also the conversion of the code is line by line. So by that I mean that if you have 20 lines, the first line would be converted into bytecode and then it would be executed. Next, second line would be converted into bytecode and then it would be executed. So this is the whole process for executing the Python program. So the whole file is not converted at once as it is done in case of compiled languages like C, but here the execution would be dependent on how long the program is. Execution time will depend on how long the program is. So that's why sometimes it's told that the interpreted languages are a bit slow. But I would say that given the recent developments and the support which Python language is receiving, because of that, it is becoming quite fast and efficient in its execution plans. So nothing to worry about that. Uh, in terms of speed and execution, it might be a minus point, but in my day-to-day use of Python, I have not yet come across any case where, because of the execution speed of Python, my work was done very slow. So yeah, nothing to get worried about. Next, we have a portable point, which means that earlier also I explained that by being portable, it means the Python code on Windows machine can be executed on macOS, because the interpreter which is executing the Python code is machine dependent and not the code Python code which was written. Further, we have 2 points, more 2 points, which says it's a free and open source, and also it has huge library. So by free and open source, it means that anyone who can install and use Python can write programs in Python, and also since it's open source, we can make contributions to it too. By huge library, we mean there is a lot of libraries which you can use for external applications like data science and analysis, data computing. So this collection of use library helps Python to be applicable in many domains. Lastly, we have the cross compilation points. By cross compilation, we mean that Python language code can be converted into either Java, C, or JavaScript code. So for this purpose, we have specific compilers which we need to use. So yes, so cross compilation is possible using these compilers. If you want to know more about the history of Python, you can visit this link. No need to copy the link right now because I'll be sharing the slides through my GitHub account, so you'll be able to access them later. Further, we are going to move ahead to installing Python. So there are certain steps we need to follow in order to ensure that Python is installed properly. So first, what we have to do is we have to download the Windows installer, because my system is a Windows machine. So, but if your system is Mac OS or Linux, you need to download the other installer setup. So what I'll do is I'll head to python.org backslash download, and here we can see that the latest version for the Python is 3.9, and I will head to the section below where it says looking for specific release, Python release by version number. So if you're not able to get to this page, you can get to python.org and then navigate to downloads and then to Windows. So you will reach to the Windows page specifically, but here I was on the general page which says only downloads. So from here I will click on the latest version and then head down to the section where it says files so that I can have my installer. You just have to click and it will auto download. For me, I'm not going to download the installer because I already have it on my hand, and I'll just double click it and install. I'm not sure whether you're able to see the screen, but here now I'm getting a prompt from administrator that it is asking me for permission, so I'll click yes and it should go ahead. So yes, the installation is progress. Today it's running. Today it's running quite a bit fast. To be honest, I did try installations quite a bit of times, but every time that the total time it took was not fixed. So I'm not sure how long it will take, but usually it's less than 5 minutes, so nothing to worry about that. And also the thing is, you don't need to um, wait for any prompts during installations. It's just one click go and you will be done. So we'll wait here for a bit. I think it's around to be completed. Yes, seems pretty good speed for this set today to get completed. Mm, Waiting for it to get complete. After it's completed, we just have to click on close and then we can verify our installation through a sample program. So yes, yes, before we get done with the installation, actually I missed one point here. So I'll just relaunch this application. If I click on modify, is it showing me? No. Okay, so it's not showing me that option, but the option was is when you double click and do your first installations, there will be an option to add Python to your path. So remember to select that because what it will do is instead of installing only for your user, it will be installed system wide and every user can use. So be sure to select the add to path option when starting with the setup. Moving ahead, we will verify our installation. So yes, to check the installation, go to command prompt and type Python. So I'll head to command prompt. So I have opened a run window and type cmd in that to open the command prompt. After that, I am going to type Python here. Okay, it's not recognized because I have not added it to the path. So that was the main issue. Okay, I have to resolve this first. So I'll pause the video here for a moment and then return back when I have resolved this issue. Okay. Yes, we are back and I was able to resolve the issue. So the issue was that I was not able to run the Python command because I did not select the add to path option, even though it was installed. So now I'm able to run the command. So to verify my installation, I will type Python and then press enter. So here we can see the chevron prompt, which verifies that Python is working correctly. To exit this prompt, we will do Control Z and then press enter. So it will it will exit the Python prompt. Going back to our um, presentation, we'll move ahead with the next slide. So the next slide is running Python program. So here we have a sample program which says that write a program to calculate a cube of 2 and then we will run the above program using the Python command. So this is just to give you uh, a peek into how the script mode works in Python. So I have already went ahead and created this program. This is a very small program, and here you can see I have used variable to which I have assigned a number and then I am printing it, the cube of the number. So I will run this program. Full file path to clipboard. Here I will come Python, put this braces, sorry, apostrophes and paste this thing. I'm using these double apostrophes because I have a space in my name, so I have to be sure that I used them. Press enter and here we have our output. Uh, so this was how you use Python in script mode. Further, moving to debugging, we have syntax error. First one is the syntax error. So these errors are basically the errors which you make or during typing the Python program. You can refer them as to a typo or maybe using some other name for a function. So for example, if you're thinking the function would be print line to print the given data on the screen, but actually in Python it's just print. So that can be some syntax error. Further, we have runtime errors. So these are basically errors which you encounter while running the program. So this can be that you are accepting an input from the command prompt and you're trying to convert that into an integer. So the error here can be that you entered a float number and when you're trying to convert it into int, it will give an error because it's a float number. So that can be a good example for runtime error. Further, we have semantic errors, which means that the logic of the program is not what you intended it to be. So here the example can be that um, you are trying to extract the last digit for a given number. So the given number is 456. You're trying to extract 6. So in order to extract 6, you have to use the modulus operator. But instead of modulus operator, we are using the division operator. So that might not give you the intended functionality. So you have to change it to modulus operator in order to get the last digit. So this is a good example for semantic errors. Further, we have experimental debugging. So by this, I mean that you have written your program and then you want to know that whether my program will work or not for a given input. So in other words, you want to conduct an experiment on your program to see whether it works for a given input or not. So that is known as experimental debugging. So first we have a sample program here. I think I have written this sample program. Yes, so here what I'm doing is I'm accepting a number from command line, converting it into integer and then printing it. So we will run this program. Here we'll be having Python and again double apostrophes, inverted comma. Okay, press enter, enter number 8. So for 8 this program works quite well. But what about our case of experimental debugging? I want to conduct an experiment on this. Okay, let's go back to slide. Do experimental, what we have to do is do experimental debugging for the case of entering a float number from the command line. So for this program, I will run the program again, test program 1. I will enter 5.3, which is a float number, so it will give an error. So now through this experiment, I know that my program is not working for a float number. So I have to go ahead, make some changes to my program so that it works for both float and integers. So I will type in float here, come back, clear this to get some space, run this program again. First, I will test for my float number. It works well. Then again, I will test this for my integer number. It works for integers too. So this is how we do experimental debugging. Next, moving ahead, next we have our slide for formal and natural languages. So the major difference between formal and natural, not major difference, but one of the difference would be that natural languages are the languages which we usually use in our daily conversations like Hindi, English, French, and other languages. But formal languages are languages which are designed for specific applications like mathematical language, chemical structure language, and programming language. Um, another major difference, not another major difference, but a major difference about between formal and natural language is that there are strict rules for using formal language, but when it comes to natural languages, the rules are not very strict. So that can be observed from the case that where for when in the case of English, so English used in UK would be quite different when compared to English used in India, US, and Australia. So the rules, people might bend the rules a little bit to make them suitable for their conversation. So that will be there. But in case of formal languages, the rules are not bent because the interpreter which interprets this formal language has no leeway for or exceptions for any shortcomings. So here, those rules are defined through syntax rules and they basically contain of two things. First is the token and second is the structure. By token, I mean that it can be words, numbers, or chemical elements, and structure is how these tokens are arranged together in a legal way. So through parsing, we will come to know that whether the structure follows the given syntax rules for a language. So parsing is also quite important for a formal language. Moving further, lastly, we have our slide for the difference between round brackets, curly brackets, and square brackets. So first one is the round brackets, which can be used to define any tuples and also expressions. Mhm. Yes, next we have the curly brackets, which can be used to define dictionaries. Dictionaries basically contain pairs, and those pairs are made up of keys and values. So this dictionary is basically helpful in fast lookups. Then we have the square brackets. Square brackets can be used to define dictionaries. So not dictionaries, but list. Sorry, it was my mistake. It can be used to define list and also to access dictionary elements. So inside square bracket, we specify the key for the dictionary, which will return back the value. So that's it for now. This was the first lecture amongst many more lectures to come. So feel free to provide any feedback over the lecture contents or the slides and hit the like button. Again, thank you so much for listening to me and watching this video. I'll see you in the next lecture. Thank you.